again. Today we're going to be looking at 7.4, which is basically applications of linear systems, which in a nutshell means word problems. I know how much you guys hate those. It's always a good idea to have your book with you when you are watching these videos, but especially today, because of the word problems, I am not going to be able to write the entire question on the board. So make sure that you have your book with you. If you need to pause right now and go get it, do that and come back so that when I read the problems, you're not lost. I am on page 365, as you can see there, and I'm going to do 3 examples for you, numbers 1, 3, and 7, and hopefully that will give you enough of a jump start into how to do these word problems. I will say before we get started that in general, when you're doing these word problems, you are looking for 2 different equations that you need to come out of the problem. So as you read through the problem, there's always going to be options, 2 options, either 2 types of something, or 2 people, or 2 road trips, 1 coming, 1 going. And that's how you're going to set up these 2 separate equations in general. And I'll show you what I mean by doing number 1. So number 1 reads, Tyrell and Dahlia, or Dahlia, however you would pronounce that, bought some pens and pencils. Tyrell bought 4 pens and 5 pencils, which cost him $6.71. Dahlia bought 5 pens and 3 pencils, which cost her $7.12. Let A equal the price of a pen, let B equal the price of a pencil. And then it proceeds to ask us a series of questions. So we're going to solve this number 1 here. The first thing that you probably want to do with the word problem is to create define your variables, which they've kind of done for us in this problem. They told us that A is going to be the price of a pen, and that B is the price of a pencil. And again, this was already given to us in the problem, so we don't really have a choice in this case as to what the variables are going to be. In the future, you could use X, Y, whichever letters you want to use. And then we're going to go back, and it says in part A, write an equation that relates the number of pens and pencils that Tyrell bought. And so again, you see what I was talking about with the 2 different types of something. You have 2 different people in this case. We have Tyrell, so he'll have an equation, and Dahlia will have her own equation. Okay, and I think that you guys know how this works. You have an item that you want to buy. It has a certain price to it. So if an apple costs 10 cents, then you buy 2 apples. It's going to cost you 20 cents because you take 2 times 20, or sorry, 2 times 10, you get 20 cents. In this case, the price of the pen is A, and according to the problem, Tyrell bought 4 pens. So he's going to buy 4 times the price of the pen, which is A. So 4 times A will be the cost of his pens, and it says that he bought 5 pencils. So in addition to the pens, he bought 5 pencils, so 5 times B, because again we're multiplying the cost of the pencil times how many pencils he bought. And it tells us that combined, when he bought those pens and pencils, he paid a total of $6.71. And that's equation number 1. And in a similar fashion, we find Dahlia, and Dahlia, it tells us, bought 5 pens and 3 pencils. So she bought 5 pens and 3 pencils and spent a total of $7.12. And that is pretty much the hard part of the word problem, setting it up, because of the words. People have a hard time doing this part. Now that we've set it up, you can use whichever system you'd like, either substitution or elimination, and hopefully you watched the video already on elimination, and we can solve this either way. I'm going to go ahead and use elimination, and to do elimination, I'm going to try to cancel the b's, and so I know that if I multiply the top equation by a -3, that will become -15b, and if I multiply the bottom equation by a +5, this will be +15b, and the b's will cancel. So that's what I'm going to do. 4 times -3 is -12a, so this is -3 times 4. -3 times 5 is going to be -15b, and -3 times 671 is going to be $20.13. -$20.13. Okay? And now we go to the second equation, and 5 times 5 is 25a, and 5 times +3 is +15b, and 5 times 712 is $35.60. And you can see that when I add these two equations together, as is the custom when we're doing elimination, the 15, the positive 15, the negative can be canceled. But 25 minus 12 is going to be 13. So you get 13a equals negative 20.13 plus 35.60 is going to be 1547. And we divide that by 13. So now 1547 divided by 13 gives us 119. So A equals 1.19. And if we go back to your definition of your variables, we know that A represents the price of a pen. So now we know that the pen costs $1.19. And using A, we can plug it back into one of these equations to get the price of the pencil. And we're going to do that next. So 4 times A plus 5B is equal to 671. And we know from here that A is $1.19. So we plug in $1.19 there. And we get 4 times $1.19 is 476 plus 5B equals 671. Subtract the 476 from both sides. And 5B will equal 671 minus 476, which is 195. Divide by 5. And B equals 0.39, which means the price of the pencil is now 39 cents. And the price of the pen was $1.19. So the pencils are cheaper than the pens, which makes sense because they're probably cheaper to make. So those are your answers for this problem, and that's how you solve that question. So now we're going to move on to number 3. And it is important that you have all of these examples in your notes so that when you come to class, we can use them to sorry, I keep writing the wrong thing there. This is actually number 3 in your textbook, also on page 365. And number 3 is a little bit trickier. I'm not really going to use the table that they're using in the book to do the problem, but it's pretty much the same thing. So again, I want to remind you of what we said earlier about the 2 different types and the 2 different equations that we're going to want. It says here, suppose you want to combine 2 types of fruit drink to create 24 liters of a drink that would be 5% sugar by weight. Fruit drink A is 4% sugar by weight, and fruit drink B is 8% sugar by weight. So we want to solve this system, and again, they're using a little table, but I want to kind of use the same scenario that we had in number 1, which is to define your variables. Right away, you want to say what A represents and what B represents. Okay, so we're talking about liters. There's 24 liters of fruit drink. So we're going to say that the 2 different types of fruit drink are A and B. So this will be liters of type A, and this will be liters of type B. Okay, so that basically just means that's how we get our first equation is, what is the total amount of liters that you have? According to the problem, if I take the liters of A and add to the liters of B, I have a total of 24 liters. Okay, it says that in the first part of the problem, it says, suppose you want to combine 2 types of fruit drink to create 24 liters of a drink. So combining the 2 means addition, and I want a total of 24 liters. That's my first equation. And then you have all these percentages. Okay, so we have that fruit drink A is 4% sugar. Well, 4% is 0.04. So now we're going to do here total sugar for our second equation. Okay, we need 2 equations. Our total sugar. Well, drink A is 4% sugar according to the word problem. So that means that it's 0.04 times A. 4% of the drink is sugar. And then for type B, it says that it's 8% sugar by weight. That's 0.08. And then it says that you want to create a 5%. So basically what's happening is you have one type of drink that has a little bit of sugar, 4%, and one that has a lot of sugar, 8%, and you want to mix the two to create one that's going to be 5%. And when you're done, when you mix the two, you're going to end up with 24 liters of this. But it's going to be 24 liters at 5%, okay? And there's your equation. So this represents how many liters do I need of this type, how many liters do I need of that type, so that I end up at the end of the day with 24 liters of a 5% type, if that makes sense. So those are my two equations, and so now I'm going to solve the equations. And in this case, it's actually easier to solve this one by substitution because of all these 0.08s and 0.4s. It's actually easier to solve by substitution. And if you recall substitution, you take one of the two equations and solve for one of the letters. So the easiest way is to pick a letter that has a coefficient of 1. And in this case, we're lucky because we have two letters that have coefficients of 1. These do not have coefficients of 1, so I don't want to try to mess around with the second equation. I want to mess around with the first equation. So I can pretty much subtract A. This is not the only way to do this, but it is an easy way to do it. And if I subtract A from both sides, then this equation will become B, because these A's will cancel. So I will get B equals 24 minus A. So now I have this equation, and so the easiest thing to do is to now replace or substitute B with B in the second equation. So here we go. I'm going to get 0.04A plus 0.08, and instead of B, I'm going to replace that with my previous equation. So this all stays the same. Okay, but I'm going to take my 24 minus A, and since B is equivalent to 24 minus A, I'm going to replace this B with 24 minus A. And now I have an equation that's all one variable and therefore easier to solve. So we're going to take 0.08 times 24, which is 1.92, so 0.04A, that stays the same. When I multiply 0.08 times 24, I'm going to get 1.92. And then I'm going to take 0.08 times negative A, so that's going to be minus 0.08A. And then it's going to equal 0.05 times 24, which is 1.2. So now I can combine my A's. So 0.04 minus 0.08 is negative 0.04. So I combine my A's. I subtract the 1.92 from both sides. So I get negative 0.04A is equivalent to negative 0.72. Divide by negative 0.04, divide by negative 0.04, and then this cancels, so in the end, A equals negative 0.72 divided by negative 0.04, which is 18. It's funny how that came out to a nice even integer. So that means that I need 18 liters of type A. And if I need 18 liters of type A, I can come back here really easily and figure out that B would have to be 24 minus 18, which is in fact 6, right? I think in most countries. So I need 18 liters of type A, 6 liters of type B, combine those two, and I will have my 24 liters of 5% solution. So that's how you do that type of a mixture problem. And then we have one more example to do for you, and it's more of a distance and rate type problem. And that is number 7, and it is on page 366. So it reads, a family is canoeing downstream with the current. Oh wow, that's really thick. Let's not do that. Sorry. A family is canoeing downstream with the current. Their speed relative to the banks of the river averages 2.75 miles per hour. During the return trip, they paddle upstream against the current, averaging 1.5 miles per hour relative to the riverbank. And again, it's going to ask us to write a series of equations and then try to solve the system. And again, I'm going to do it with my method of using two types. So the first thing you want to do is define your variables. So I'm just going to call x and y. Okay? And what's happening in the problem, if you're not understanding, is you have a family that's paddling. Okay, they're like paddle, paddle, paddle. And if the water was still, meaning there wasn't any current, then we're going to call x the paddle speed in still water. Paddle speed in still water. So if the water wasn't moving anywhere, they're paddling at a certain speed. We don't know what that speed is, but we're going to call it x. Y then is going to represent the current speed, how fast the water is moving, so the speed of the current. Now, why does this matter? I don't know if any of you have ever gone canoeing, but if you're paddling and you're going with the current, then the current is helping you, and it's a little bit easier on you to be, paddling because the current is helping you go faster. And then if you go against the current, the opposite is true. It becomes a lot harder on you because it's now going against you and pushing you back when you're trying to go forward. So it's a little bit harder. So basically what's happening here is either the speed of the current is helping you or it's hurting you, making you go slower, if you will. So those are our two variables, and here's our first equation. We know that from the problem that when the family is canoeing downstream, which means the current is, it says with the current, then it's basically going to take there, so we're going to put here downstream. We know we want two equations. We want an equation for downstream, and we want an equation for upstream. Okay? When you're going downstream, you're going to be paddling at your speed, and because the current is helping you, you're going to add your two speeds together, and it's going to help you, and so you're going to be going a little bit faster, which it says you're going 2.75 miles per hour. Okay, but when you're going upstream, now the current is not working with you, it's working against you. So it's hurting you, it's making you slower. So we're going to subtract the current, the speed of the current. And of course, you would expect that you'd be going slower because it'd be harder. And it does in fact say that on the return trip, you're going against the current and you're averaging 1.5 miles per hour. So you're going a little bit slower because of that. But there you go, those are your two equations that you need. And this problem actually is perfect for elimination, because you already have opposite signs, positive y, negative y. So if I basically take these two equations right now as they are and add them together, it'd be really easy to solve. X plus x is 2x. Positive y and negative y cancel, so they eliminate. And then 2.75 plus 1.5 is going to be 4.25, I think. So 2.75 plus 1.5, always be sure. 4.25. Divide by 2, x equals 2.125. So basically, you go back to your definition of your variables, and when it's x is your paddle speed in still water. So basically, the little family is paddling at 2.125 miles per hour. And then you can find out what the speed of the current is, because that's y, and you can plug it into either one of these equations. So I'm going to say that x plus y equals 2.75. So basically we have x is 2.125 plus y equals 2.75. And I subtract the 2.125, and I get that y is equal to 2.75 minus 2.125, which is 0.625. So the speed of the current is not that strong, but you'd be surprised at how little that can hurt you or help you when you're paddling in a river. So those are the three examples that we have for you. This is exactly what we'll be doing in class on your homework. So be ready to attack some word problems next class period. Thank you for watching.